Hey everyone, it's Miss Lloyd, and I am looking at solving some trigonometric equations with you today. These are my steps that I use whenever I'm going through trying to solve something with a sine, cosine, tangent, etc. First, I want to combine any trig functions. So if I have two sines, like we see in the example below, then I really only want one. So I try to combine those the same way that I would if I had like a 3x and a 4x. I would add those together so that I could, or combine them in whatever way, so that I would only have one x that I'm working with. Once I just have that one trig function, I'd try to get that trig function alone, the same way that we would if we were just solving for a variable. If I want to get rid of the sign that is with our x, or the cosine or the tangent or whatever it is, I'm going to use its inverse function in order to get rid of that function, the trigonometric function, and isolate my variable. There are instances where we may have to use factoring, and if there's factoring involved, you can always do u substitution. If the actual sine, cosine, tangent, like that part kind of freaks you out, you can replace sine of x with a variable, with a u, and then you can see a little bit easier how to get that variable alone. So for this situation, I am going to show you with a u substitution without. For this one, I don't think it's completely necessary for a u substitution because I just have two signs. So I want to get my signs together. So I'll add this sine of x over. I don't like negative signs. So I tend to not like subtract things over and make them more negative than they already are. And this works the same way as like if I had x plus x or y plus y, I would end up with 2x or 2y. So this will be 2 sine x because I had two sine x's. I now want to move that square root 2 over. I want the sine completely alone. And then I need to get rid of this 2 that's multiplying with my sine. Now my sine x is alone, and I can see it's equal to the square root 2 over 2. And this is something that I remember from the unit circle. So I know that when I'm at 45 degrees, or pi over 4, my sine is going to be a positive square root 2 over 2. Sine is also positive in the second quadrant, which means I'm also at positive square root 2 over 2 for 135 degrees and 3 pi over 4. So I don't even have to do the inverse sine. If I did, I would end up with some decimals, which would be kind of, well, not if I'm in degree mode. If I'm in degree mode, it would tell me 45 degrees. But if I'm in radians, it won't tell me that nice pretty pi over 4. So this, I'm just going to remember my unit circle or my trig hand trick and say, okay, this is at both 45 degrees and 135 because that's where sine's positive in those two quadrants. And if it's asking for radians, I know that's pi over 4 and 3 pi over 4. And those are my solutions. And so most of the time, depending on whatever your teacher is asking for or whatever the textbook is asking for, a lot of times you'll be looking for the radians. I'm going to ask for both for my students. My students who are taking this right now, who are looking at this right now, are my advanced students. And so I'm going to ask them to do both. You're welcome. Next one that we're going to look at, and this is the last one that I'm going to look at, and the rest of these examples I'm going to save for my students. So for this situation, so many times I see this. People want to divide by the sine of x because they see it on both sides. You cannot divide by a variable. That's not how it works. So what I'm going to do is I'm going to subtract my 2 sine x over to the other side so that they're at least both on the same side. Because one of these signs is squared and the other one is not, I can't actually combine them. Same way you can't combine an x squared and a 2x. So from here, it may be something that you look at and you think, no, thank you. And so you can, from here, do a u substitution. So instead of a sine squared of x, I could say this is u squared minus 2 times u is equal to 0. And here we can see that we could factor out a u. We have that in common. We can bring the u out to the front. So we'd have u minus 2 is equal to 0. So then I'm looking at where u is equal to 0 and where u minus 2 is equal to 0, or where u is equal to 2. So then that means, remember I said u was sine of x? So I'm plugging back in. I'm looking at where sine of x is going to be 0. So I'm looking for the angle at which sine is going to be 0. Remember, sine is our y. So if I'm on the x-axis, that means my y value is going to be 0. So for those situations, I'm looking at 0 degrees, 180 degrees, and 360 degrees. And I could keep going, like this actually could go on for forever and ever and ever. There's like an infinite number of. You could create an equation for it. I'm not going to go that far today though. If I'm looking at radians, then I'm at 0 radians, pi radians, and 2 pi. The next thing I'm looking at is when sine of x is equal to 2. So the unit circle only goes out to 1. So the largest y value that I'm ever going to have on the unit circle is going to be 1. I'm not ever going to get to 2. And you could, if you wanted to, just to give yourself a frame of reference in your calculator, do sine of the negative first, so the inverse sine of 2. And it's going to give you a domain error because this isn't actually possible. All of our sine and cosines are going to be in between -1 and +1. They're not ever going to get past that. So then this is no solution. So my only solutions are the ones for when sine of x was equal to 0. I hope you found this helpful. If you did, please like and subscribe. And if you think this could be helpful for someone else, please feel free to share it. Spread the love.